Welcome back. On my table is the box of the new orange iPhone 17 Pro Max, proceeding to peel off the rear seal. It is still the familiar paper box design from Apple. Inside is a premium braided cable. Peeling off the matte paper protecting the OLED screen, I immediately apply a tempered glass screen protector to protect against scratches before opening the device. Booting up the device for the first time, the Apple logo appears sharp on a deep black background. Quickly going through the activation steps, passing the hello screen and setting up the Wi-Fi connection, swiping up to enter the home screen. The 120 Hz refresh rate provides extremely smooth transition effects. Checking the current storage, it is 1 terabyte. Today's goal is to upgrade the capacity to 2 terabytes. Battery health is at 100% with 1 charge cycle. Now sliding to power off to ensure electrical safety, using a specialized pentalobe screwdriver to remove the 2 star-shaped screws on both sides of the USB charging port. Each screw is carefully placed into a sorting tray, placing the device on a fixed clamp, preparing to separate the screen, injecting anhydrous alcohol along the metal frame to soften the water-resistant adhesive around the screen, lowering the vacuum suction cup onto the glass, slowly turning the screw to create an even pulling force. Observe the gap slowly opening up. The strong adhesive layer is stretching under the effect of the alcohol. Separating the screen requires patience to avoid breaking the cables or shattering the thin display panel inside. The screen has been completely lifted off from this vibrant orange solid titanium frame, transferring the device to the blue magnetic base to firmly secure the device chassis during the teardown process. At the front camera area, carefully using tweezers to pick up the metal shield protecting the connection cables and sensors, using an insulated plastic spudger to gently pry up the battery cable, completely disconnecting the power to avoid short-circuiting the microchips, continuing to disconnect the cables and lifting the screen assembly out. The flat cable is made wider to achieve a thinner profile. This design is to make room for the completely revamped VC vapor chamber cooling system. The black bordered area is the specialized heatsink, tightened by 14 screws of 5 different types. The recess in the middle is the cooling module. The VC vapor chamber fine-tuned and developed by Apple themselves, removing a standard screw. It seems Apple has switched to a new screw standard. Using tweezers to lift the small protective shield out, exposing the interface area of the functional sockets. Using a specialized electric screwdriver to remove a series of frame screws to prepare for taking this large black piece out. The electric screwdriver saves a significant amount of time, with standard torque that prevents stripping the screw threads. Using tweezers to lift the entire secondary heatsink plate up, you will see the large L-shaped battery underneath. This battery has a capacity 265 mAh, lower than the eSIM version, due to sacrificing space for the physical SIM tray assembly. The internal component structure is completely redesigned. The moment it's taken apart, it really looks like an Android device. Continuing to remove the screws securing the metal brackets, protecting the socket pins. Every operation requires high precision. Using a plastic pry tool to remove the bracket and gently pry to disconnect all connecting cables on the motherboard. Continuing to remove screws and extract the metal bracket for the wide-angle camera. The component layout is very tight. Taking the protective brackets out, the screws are arranged in their exact positions to avoid confusion when reassembling. Taking the Face ID sensor assembly and earpiece speaker out of the groove, and storing them immediately in an anti-static plastic box. Removing the dual-layer standoff screws holding the main camera assembly. This requires an appropriate specialized screwdriver bit. Lifting the entire triple rear camera module out, and placing it in a glass case immediately to prevent dust from getting in. Removing the protective film of the camera gasket on the chassis. The rubber gaskets help the optical image stabilization function properly. Moving down to the external speaker and Taptic engine area. Removing the screws securing this integrated speaker assembly. Taking the speaker assembly out and using a plastic tool to disconnect the secondary microphones located near the bottom edge. Now is the time to lift the entire motherboard out. The stacked dual motherboard has an extremely sophisticated design. separating the microphone assembly and LiDAR sensor from the motherboard. Handling must be gentle to avoid damaging the flex cable. Holding the motherboard of the iPhone 17 Pro Max in hand, you can see the level of integration has reached a new peak. The main board is compact but holds immense power. The sockets are densely arranged around the edges, using tweezers to peel off the black thermal paper layer. Underneath is the NAND memory chip we need to replace, completely peeling off the protective wrap around the IC. The original NAND chip is underfilled with very hard black epoxy around the edges. Mounting the motherboard onto the clamp of the CNC milling machine, we will use the milling method instead of hot air reflow. The high-speed milling bit is gradually grinding away the shell of the NAND chip. This method is completely safe for the CPU, located right on the back. The drill bit moves precisely, micrometer by micrometer. The silicon layer of the memory chip is being completely destroyed. It is shaved down gradually until the contact pads are exposed. The milling dust is vacuumed away for easy observation of the surface. Both sides of the motherboard are exposed with tiny pads. Not a single underlying circuit trace is damaged. Step 3. Continue milling the edges to remove the hard black adhesive. This process requires the CNC machine to be calibrated perfectly. After milling, secure the motherboard onto the heatsink base, preparing for the adhesive cleaning and reballing process. Apply soldering flux onto the surface of the contact pads. Use a high-temperature soldering iron to melt the old solder. Step 3. Gently run the soldering iron tip over the copper pads. The old solder and some adhesive are softening under the heat. Add more flux and use a copper desoldering braid. The copper braid will clean up the excess solder, completely flattening the surface. A flat surface helps the new BGA chips heat more accurately. Now, use a hot air gun combined with a specialized scraping tool. Scrape off the remaining black underfill adhesive at the 4 corners. The hot air temperature must be just right to soften the adhesive without blistering the board. The scraper blade moves carefully to avoid scratching the motherboard surface. This adhesive is very tough, which is a characteristic of Apple motherboards. Continue using tweezers to pick out the excess adhesive pieces. Even a tiny bit of leftover adhesive will cause the new chip to sit unevenly. Use a desoldering braid soaked in flux. Go over the entire surface of the contact pads again. Ensure the excess solder is completely wicking away. Then, use a cotton swab to scrub the surface thoroughly. The motherboard surface is now shiny and perfectly flat. Introducing. This is the ultra-high capacity memory chip, getting ready to be installed. Place the reballing stencil over the new microchip. Apply a thin, even layer of solder paste. Fill all the holes on the steel stencil. Step 4. Use a high-temperature hot air gun and blow evenly. The solder paste will melt and form round balls, bonding tightly to the contact pins of the microchip. Step 5. Remove the microchip from the steel stencil. Apply another thin layer of rosin flux onto the surface to increase adhesion when soldering it onto the motherboard. Step 6. Align the microchip perfectly onto the motherboard. Use the heat from the hot air gun blowing evenly until the microchip automatically snaps into the correct position. Temporarily install the motherboard and screen into the frame. Plug in the connection cables to test the ability. To recognize this new storage chip, connect the device to a computer to reload the software. The progress bar runs, and the welcome screen appears, proving the recognition process was successful. Returning to the motherboard resting on the clamp. The sticker is blurred due to the cleaning solution, but it does not affect the functionality at all. Step 3. Proceed to reassemble the surrounding small components. Place the metal protective bracket in, exactly into the original latches set by the manufacturer. Place the motherboard back into the metal frame. Press gently so the latches hold the motherboard in place, ensuring it's not misaligned or pinching any cables underneath. Reassemble the external speaker and vibration motor modules. Tighten the screws to secure these components into the chassis firmly and safely. Take the main camera module out of the dust-proof box. Gently place the module into its proper compartment, and press the cable connectors onto the motherboard. Step 1. Place the protective shields over the cameras. Use a screwdriver to tighten the screws and secure this shield. to prevent the cables from popping off upon impact. Step 2. Install the Face ID sensor module back into its original position. Handle it extremely carefully to avoid smudging the surface of the sensitive optical lenses. Steps 3 and 4. Use a specialized cotton swab to clean the contact pins. This ensures the image and touch signals are transmitted as stably as possible. Step 4. Install the metal bracket protecting the connection cable area. Tighten the screws to secure and finalize the area that supplies the main power to the entire device. Continue positioning and tightening the screws for the lower bracket. Every smallest detail must be placed exactly in its original position. Connect the display cable to the motherboard perfectly. The reassembly requires meticulousness, so the cable folds in the right direction to avoid stressing or cracking the signal traces. Now, place the vapor chamber cooling pad over the motherboard. Align it to perfectly match the screw holes located on the edge of the chassis. Use an electric screwdriver to tighten the screws one by one. The torque is fully automatically controlled by the machine to avoid damaging the metal screw threads. Step 4. Use a metal pry tool to scrape off the old edge adhesive. This adhesive sticks very tightly to the frame. It must be completely removed to apply a new layer. Use a cotton swab dipped in a specialized cleaning solution. Completely clean off any remaining adhesive residue. The titanium alloy frame needs to be cleaned to ensure the new water-resistant adhesive bonds well. Continue using a metal tool to scrape clean the stubborn adhesive residue stuck deep in the corners. Swiping along the frame must be decisive, leaving no small bumps on the surface. Clean it once more with a soft cotton swab. All contact surfaces must be perfectly smooth. Move on to cleaning the inside of the screen assembly. Carefully wipe away the old adhesive around the glass edge. The glass edge is very prone to chipping if strong force is applied. You must work gently along the retaining clips. The surfaces of the frame and screen are now completely clean, ready for the application of the new water-resistant seal. I place the blue water-resistant adhesive seal on the frame. Accurately align the positioning holes at the 4 corners. Use tweezers to peel off the protective film on top of the seal. The transparent adhesive remains on the alloy frame edge. Pull slowly to separate the plastic film from the adhesive surface, to ensure the adhesive line is not broken or shrunk. Reinstall the protective shield for the earpiece speaker and sensor assembly. Use a screwdriver to tighten the securing screws. Wipe the connection cable area clean with a safe solution. Attach the final metal bracket to secure the cable connector. Use a screwdriver to tighten the last screw on the bracket. All internal components have been completely installed. Do a final overall cleaning of the inside of the phone body. Wipe away smudges and use an air blower to remove dust. Apply blue protective film onto the camera lenses to prevent dust from getting inside during reassembly. Carefully connect the screen cables to the motherboard. Fold the screen down and gently squeeze along the frame edges. Place the device into the specialized seal pressing machine. Insert a rubber pad to distribute the pressing force evenly. Lower the press lever and hold the pressure for a few minutes. The pressing force helps the water-resistant adhesive bond completely. Take the device out and proceed to screw in the 2 bottom edge screws. Tighten them with a screwdriver to lock the screen in place. Apply a sealing sticker over the bottom speaker holes. Place the phone into the specialized air pressure testing device. The pressure gauge displays a perfectly stable reading, confirming the device has restored its water resistance. Remove the sticker and check the device specifications again. The storage capacity has been successfully recognized. Run a performance benchmarking app to check stability. Everything works perfectly. See you next time.